Hello and welcome to everyone who is joining for the second episode in our natural language processing series. Today's session is looking at slaying machine learning with Buffy. So really excited to hear what we'll learn today. This session will run over the next 60 minutes. That's inclusive of any questions and answers. So any questions you do have throughout, feel free to pop them into the Q&A window. We have a moderator with us today who'll be keeping an eye on those questions coming through. So do feel free to use that at any opportunity. This session will be recorded and posted onto the Microsoft Reactor YouTube channel. So I'll send a link into the Q&A window where you can access that recording. And the recording for the episode 1 from last week is also on that channel. And again, I'll post the link to that. Just a quick word on our code of conduct before we get started today. So this is just a reminder to everyone who's joining us today to be aware of others, be friendly and welcoming throughout today's session, and understanding of differences of opinions that we might see throughout the questions and answers window today. Our speaker for today is Robin Lester. Robin is a cloud solution architect and working at one commercial partner as well. So we're delighted to be welcoming Robin back today to deliver today's session. I believe that's everything from my end, so I will hand over to Robin for now, and I'll just stop sharing my screen for you, Robin.
Thank you. I'll just share my screen. And I'm sharing my screen. Now, we have some sound in some of these sections. So if you don't hear sound, let me know and I'll reshare my screen again. Hopefully it will work. Okay. So this is Slaying Machine Learning with Buffy. We're this is part of a natural language processing series, and this one is based around Buffy the Vampire Slayer. So if you haven't watched Buffy the Vampire Slayer, why not? But you don't need to have watched any of the episodes for this presentation. Some of it might not quite make sense. There are a few links in it, but you should be okay because we're mostly talking about the technology. If you're a partner and you're watching this session, please join the UK Partner Technical Community. That's uk.ms/aptc. Paul, I'm sure I can paste that link in. Like I said, this is part of a bigger series. So we ran one last week on Rom-Com or Not, talking about natural language processing, trying to understand the difference in genres between different films. So that is recorded and that will be available on demand. This one is about machine learning generation. Next ones we have next week: overview of Azure NLP solutions, then topic modeling with machine learning, converting audio files into text with Azure AI, fundamentals of text mining, state-of-the-art language models, and then question and answering with Kaggle Chord. So eight within the series, and if you join this one, you're right at the beginning, second one in. So the whole premise of this, how we go creating a new Buffy episode with machine learning. Why are we doing this? Because it's a good run through of different technologies we can use. We have a good corpus of information in terms of all of the Buffy episodes, so it's all 7 seasons. We've got a lot of text to work with, and it's something that a few people, hopefully most people, but a few people can relate to if they've seen the series, so they can understand the kind of text that we're generating. Now, obviously, lots of intertextual links in terms of Buffy. So apologies for that. Like I say, you should still be able to get stuff out of it if you haven't seen Buffy the Vampire Slayer. Obviously, there may be some spoilers if you haven't watched it. It's quite an old show, so I would expect everyone to have watched it. And we put this together before all the controversy that happened around Joss Whedon, and before all the talk of doing a reboot of Buffy. It doesn't really affect what we're doing. We're presuming that the series ends at the end of season 7, which it does, and we're trying to create a new episode after season 7, so season 8, episode 1, effectively using machine learning. The scripts I'm going to be using today most of it is on Git. So if you do aka.ms/robinnestor-git, that will take you to GitHub page where we've got lots of different machine learning notebooks in there. One of them will be the stuff that we're showing you here. Agenda. So we talk about how we got the training data. We talk about how we would cast new members and different ways we could do that for the new series. We're going to work on understanding previous episodes. We're going to create a new episode using machine learning, different machine learning techniques there. We'll do a screening of that episode. Now we haven't got, we didn't go so far as to create actual fake actors, but we kind of like the radio edit of a new machine learning episode. And after that, if we've got time, which we may not have time, we'll talk about other natural language processing techniques. We'll talk about sentiment analysis and talk about some of the newer stuff that's coming out in terms of semantic search. We have now recently released as part of Azure Cognitive Search, and how that helps you do natural language processing very easily and quickly. So Buffy season 8. Now hopefully you don't feel too old when you watch this. All the actors have aged quite a bit since the first episode. This is basically our poster for season 8. Like I say, we're going to actually create the text for it. Okay, so first thing we do, get some data. So I'll just really briefly talk you through the process of what we did. So I found a site online where we can go in and we can get all the Buffy episodes. So effectively just a few snippets in Python. Go through, and I think I put this code in the GitHub so you can go and get all the scripts yourself. I didn't write the scripts out. This is not my these aren't my scripts. Like I say, I'm borrowing from these scripts off somebody else. So take these, download them, and then I have scripts to work with, which will then form my training and testing data. I'm showing the wrong thing there. This is the script scraper. Transcripts.foreverdreaming.org. Just come out to them because we're borrowing the scripts from them. And as you can see, very simple. We just go through. We use URL lib, Python language, beautiful soup, and run through, bring all those scripts out, and then we have all the Buffy scripts. Now, so we should talk about data quality here. I haven't done really anything in terms of data quality. We've still got headers and footers on this. Some of them of these scripts don't have proper carriage returns in them. Other ones have maybe got bits in that aren't quite right. So we could probably, all the stuff we're doing, we could probably improve if we did a data quality step. Like I said, I didn't do a data quality step, but we still get reasonable results out to the end of it without doing that. So I'll close that because I've already run that and I've uploaded all the scripts. And also, it's just showing you there, Visual Studio Code. So Visual Studio Code, you can run Jupyter Notebooks in there. So when you see me running Visual Studio Code, I'm running locally. When you see me using Jupyter Notebooks in a web interface, then I'm running on Azure Machine Learning Compute. But I'll talk you through that when we get there. So first thing we're going to do, we're going to create a new episode. So what are we going to do with the actors? So we're going to use the existing actors, we're going to get new actors, we're going to get digital actors. So let's talk about if we wanted to get people that looked similar to the original actors because they've all moved on and started doing other things, and they may not be open to coming back and running a new episode of Buffy. So one thing that we can do is we can use some of our cognitive services to get to understand if we are going to be able to bring in find people that are similar. So let's just run a quick demo here. So 1 second while I am loading. Okay, and so I'm going to create in Cognitive Services. I'm using the Face API. I'm going to create a face list. I'm going to load. That's fine. I'm going to load all the previous actors from Buffy into my face list. As you can see, they're loading in. So if you've seen the episode before, at the series before, all of these should be pretty familiar. And now we've loaded them in, I start thinking, who are we gonna cast as who? So we want people that look similar to the original actors. So we can do that with Cognitive Services. We can do that with face similarity. So I can load in and I can, for example, let's try an easy one. So Eliza Dushku played Faith, and we should be able to see that, yes, she is very similar to Faith because it's the same actress. This is Irene, who is in real life was Dawn's sister, so maybe she's available for work. If I can't remember the actress's name, if she's not. I thought maybe I could. Oh, in fact, let's do this one first. So let's say Sarah Michelle Gellar is not available. Let's see if her mum might be available. And we can see that the family similarity. Yes, we see similarity there. I was thinking perhaps myself. Maybe I could play Angel or someone. Unfortunately, I am Principal Snyder. Is the character that I most look like, unfortunately. So 24% similarity. And we could try maybe Putin, and Putin actually does look a bit more similar, so if he was available for acting, maybe we would use him. Okay, but that's not language processing at the moment. We're just thinking about actors. Let's move on to start talking about more to do with the natural language processing. Oh yeah, but first off, there are a few other things that we could do. So we talked about having similar actors. We could also go and we can create new digital actors. So you may have seen the deep fake stuff out there. This basically lets us create use deep neural networks to be able to create new people effectively. So there's this interesting website. This person does not exist, and that website basically will create a new person. This person doesn't exist. It's created by a deep neural network. Run it again, I get someone else. Run it again, I get someone else. So maybe we could start to take some people, some new actors. We don't have to pay them because they're not real people. And so now we've got a face against the new people that are going to play in the new Buffy. So it's pretty good. You may have seen things like this. So this is taking that deep fake and let's mute this. So hopefully you can hear the audio. If you can't hear the audio, let me know. Just want to make sure that audio is working okay. But this is not actually Kim Jong-un talking. It's a deep fake of him talking. So we could go down that route. Now, I didn't actually go down that route in the end to create it, but we did create the actual NLP new scripts. Okay, so just talking about some of in doing this, there's a lot of ethical concerns in the stuff that we're doing when we're creating new things, new scripts. There's concerns around there in terms of ethics. If we went down the deep fake route, there's concerns about there. Creating up voices, which we're going to do. We're going to create some new voices to play the script. Obviously ethical concerns, how that technology can be used. Recently there was a case where some groups were able to scam an organization by loading in the CEO's voice into a deep neural network and then have an audio conversation with someone in one of their branch offices to then ask them to transfer some money, which they did because it sounded just like him, and the organization lost $250,000. There's also other things quite interesting coming out. So we see this new story came out I think a couple of days ago. Could the Simpsons replace its voice actors with AI? Well, yes, we're almost on the cusp of that, and I'll show you some examples of that. We now have the ability to run deep neural network voices that sound extremely similar to human voices. Okay, so understanding previous episodes, probably we need to do that to understand future episodes. So we'll just run through this and show you some other ways we can do it. So we have in Azure, let's close that, the video indexer. So I've put in here Buffy the Vampire Slayer episode, and I can see all of the people in here. I can see where they all appear. I can open the JSON for this to see all the script and all the text and where different people's faces are. We can go through, we can look at all the different topics that the different episodes are around. So we might use this in our machine learning. It's interesting, there's boredom appears to be at the start of it. I think some of the characters were saying that they were bored. They're talking about Slayer. They're talking about songs. We can see all the keywords from an episode, and I don't really have to do anything. I just have to upload an episode, and Azure does all of this processing for you. So this is called the video indexer. We can see all the labels of where everything is happening. So we can see, that's interesting one, feathered hair. So let's see why it thinks there's feathered hair in this. Okay, so maybe it's seeing that it's feathered hair. We can see there's someone has a lighter at one point. So, wow, yeah, so I can understand why it thinks lighter is a candle. We can also see all the different people in here. We can see all the browns as well. So I actually added some browns into here. So in this episode, there was talk about the spring fling and the gallery. So I said, well, actually, those are two browns that we might be interested in an episode if we were, for example, owned the gallery or something to do with the spring fling. So we can look at those browns, and where are we? So spring fling, it gets mentioned several times. So they're talking about spring fling there as well. And then see, so we can go through and can identify the exact parts of the video where these things are taking place. Okay, so let's move on in the interest of time. Now, so we've done all that. We've looked at all the different episodes. So next thing really is to start looking about how we're going to go about and create a new episode. So we're going to use some text generation to do that. Now, like I say, we're going to use multiple techniques, and I'll show you some of them. It's not an exclusive look at every possible technique, but I'll show you some of the kind of core ones. So within this, I am using Azure Machine Learning Studio, and I'm using compute within here. So I'm actually using a GPU machine to run this on. I'm only built for the time that it's running. I've actually got two. I've got a I'm going to run a GPU one for doing this first set. For the next set, I'm going to use another GPU one, but I've changed it a bit. I've installed the previous version of TensorFlow, and we're calling that. So I've called it's basically to run the GPT-2. I'll explain what that is, but it's basically a type of transference learning that we can use for natural language processing. So I've got these two running, and so all the demos I'm doing as web interface will be running on that. And like I say, nice, cheap, and easy to use. But obviously get the power of NVIDIA GPUs as well to do. So we're going to be doing some deep neural networks. Right, so let's close some of these. Okay, so this first one here. So we're going to create some text for an episode. So first thing we do, we're loading all our variables, and we're going to connect to the Azure Machine Learning SDK because we're going to store our scripts back against there. Sorry, not scripts, our experiments. When we run our experiments, we're going to store our experiments back against there. So the first thing I did, I created a function. This function basically loads in all the scripts from my Buffy scripts folder, and as you can see, there's quite a lot of text within them, so it's giving me a nice corpus of information to work with. I then run through and I look at all the different characters that I have within these scripts. So as you can see, it's pretty much the whole alphabet in terms of all the things I have in here. And like I say, I didn't do too much data quality, so I've got some weird stuff in here that probably shouldn't be in here, such as ampersands, percent marks, hashtags, etc. So those are all the digits I have. So I'm going to for this one, I'm going to split up all of my scripts into sets of 40 characters. Now, why 40? 40 seems a reasonable amount. I could go further, I could go less, and that might improve the how good the scripts I get out the back of it. But you know, these variables I can play with. But we're going with 40. So so I take my data, and within it I go basically creating lots of these different sentences. So of all 40 things. So This one is from I think season 1. Jim is cool. You can see the whole. As you can see, we're breaking it down into sets of 40, which we're going to use to train a deep neural network. Okay, so what are we going to do? So deep neural networks, a really brief overview. I'm not going to go into too much detail on the basics. We will talk a bit more about the types that we're going to be using as part of this. But essentially, I always think of deep neural network as a brute force attack on trying to get the data correct at the end of it. So we push our data through. We have lots and lots of layers. We have lots of neurons in those layers. We have all of these synapses will talk to the different neurons and give different weights in accordance to how the network thinks it needs to behave. Data will flow through, we'll get an output, we'll look at that output, we'll say, is that good or bad? If and so basically an error rate, we run back, we do back propagation, we run through change of all our weightings on our neurons and synapses, and we run through again. And we do this hundreds and thousands and millions of times until we get results that we want to see at the end of it. And essentially that's simplistically how a deep neural network works, just running that data through. And we run, and how we work out the error rate, we basically do a procedure called gradient descent, where we look at where we are, look at where the error rate is, try and tweak some features of that, and if error rate gets better, then we're doing well, so we keep tweaking that direction. If the error rate gets worse, we're doing worse, so we stop and we change to start trying some other ones, and we keep tweaking and tweaking until we get into the lowest possible error rate, and we just keep going until our error rate gets as low as possible. Now, if we were to run a standard deep neural network on this data, we would get the problem with this approach is it doesn't understand the context of what has happened before. And that's quite important in natural language processing. So if we were saying putting through in this example, we've got written text. So we maybe put through a G, it goes through, understands what a G is. Then in this case here, we might try and spell Buffy. So B-U-F-F-Y. If that Y it thinks is a T, and it's badly drawn Y, so it will place that as T, because it doesn't have the context of the B-U-F-F that came before it. So what we need to do is we need to think about how we can feed that information back in. So when our deep neural network does the training, it understands the context of where it is in terms of a word or a sentence to understand what comes next. So this is where recurrent deep neural networks came in. So recurrent deep neural network, we train, and then we run another training. But we're holding the information between the different training runs, and we back propagate through time to previous ones. So if we had B-A-F-F-Y, we might have got, by the time we got to Y, say, oh, actually, we're going to go push backwards, and we need to change that A to a U, because now that makes more sense to do so. So basically we're training, and then we go backwards in time to process through and train again. So that's one technique. We're not going to use that technique because it does have some problems. You get a vanishing gradient descent. As the more layers and the more iterations you're going through, the more chance that the error rate is going to get is going to disappear so much that you can't actually change your neurons, and then it doesn't improve itself. So that's why long-term, short-term memory, short-term memory rather, was invented. So this is a type of neural network, which is the one we're going to be using for some of this. We're going to go through, and it understands the context of what had come before. So you go through word by word in the sentence, and it has the memory of the other words that previously happened in the sentence, so it can then understand what might be the next thing. And in our case, we're using characters, so it understands what the next character should be. So essentially, we've got an input gate, we've got a forget gate, because at the end of a sentence, you might want to forget what happened before. At the end of a word, you might want to forget all the bits before, and then we have an output gate. So this will iterate through all the individual words or characters to then work out the next one. This is an iterative process. Bear that in mind when we come on to start talking about some other techniques, but it will go through and loop through and just try and do the best it can to do it. Okay, so we create a deep neural network. So we're creating a sequential deep neural network. The first layer is an LSTM, and then we've got, in fact, in this one, I've got 2 layers of LSTM, and then I've just got a normal dense deep neural network as well, and then it pushes out the results. So we can actually have a bit of a clearer look at what we're doing here. Input layer, LSTM, we drop out if depending on the error rate, and then we have another LSTM, then we have a dense layer, then we have the activation. So we can run this on our CPU. So either here's one I ran before. This takes about well, it takes about, I don't know, 20 seconds to run through 15 iterations. So, and as you can see, our loss is getting better. So as we train this, it's actually improving. If we ran for more iterations, it would probably get better and better and better. And as you can also see, I'm recording this experiment. So I'm saying experiment, and I'm putting in WS. This is the workspace. So this is the workspace in Azure Machine Learning. And I'm recording, telling it that my experiment is starting, recording history of it, run it, logging, all of these different things. So like I say, I've run this before, but I could, because I've run this before, I can always go back and I can go in and see what happened with my different experiments. So I go to my experiments, I can see that I've run it 14 times. I can see different run numbers. I can go into individual experiments. This was maybe the last one I ran. And I can see the different metrics. So this one I ran 15 epochs, that one through my minimum loss. I can actually see my loss chart, etc. So these are all being stored up against Azure Machine Learning. And I can add more things if I want to. I've also stored the model against it, so I can go in and retrieve that model if I want to as well. So that's run. And so in this part here, I go in and I download all those experiments. So basically, I'm just going back up into Azure Machine Learning Studio. And one of the benefits of using Azure Machine Learning Studio is that you can go back and you can look at it. I could say, I could bring in, if this was something where I had accuracy, I could bring in all the accuracies and find the best accuracy. This is not, it's subjective, the accuracy is subjective somewhat because we're creating text. So there's no real right answer to what is the next word that's coming in a sentence. Okay, so we run this, we iterate basically through all our experiments and bring them back. And so you can see I've run this different versions of it. So I've got one that I have only 10 epochs. I've got one where I've run up to 515 different epochs. So the more we run, hopefully the better it will get up to a point. So get the run that the 10 run epochs, just so we can see the difference. And then we can go through and let's run that. And I'm giving it a seed here. So I'm saying the seed, Buffy, let's go kill some vampires, Faith. So it's now its job is to construct the next part of the sentence for that. And I'm telling it I want it to run 500 times after this, 500 characters after this, to give me the start of a new script. So let's see how well it's done. So it said, Buffy, let's go kill some vampires, Faith. And then it goes, that willow, it's a stake with the master's lair. Buffy, well, I was a little good and was a student, and the books and the stake that starts to get off with the stairs. So not doing too good on 10 iterations. Let's run 515 iterations. So it shouldn't be improving all the time. In fact, I won't run through that. It takes about 20 seconds. We'll just show you how I ran this slightly earlier. So this is, again, same thing, but with a larger model. So again, Buffy, let's go kill some vampires, Faith. The door, Buffy, to Buffy. I don't know it of the books. I don't know it to be too good. Well, I don't know. And start of the hall. Well, I don't know her was a stake. It's trying. It's not that good, but it's trying, and it's to understand the concept of someone's talking. It is just Buffy that's talking at the moment. So it's okay. Maybe we start to tweak things. Maybe we start to say how large the sentence size is and tweak that. Maybe we start to go through more iterations. Maybe we change our deep neural network to go a bit deeper. But at the end of the day, it's okay. It's okay. It's something to work on. Now, that's one technique. We get better than that, don't worry. So the next technique you can use is a generative pre-trained transformer 2, so GPT-2. There is a GPT-3 out, but I've been using most of the stuff I've been doing with GPT-2. So GPT-3 obviously is going to be better, but this is still pretty impressive. So GPT-2, it can translate text, it can answer questions, it can summarize passages, it can generate text, which is what we're going to be using it for. So it's transfer learning, so it is a model. All we're going to do with that model is we're going to fine tune it. So this has already been trained. This is, in fact, GPT-2 was trained on Reddit posts that had, I think it was more than 15 likes, where they link to a web page, and it takes those web pages and it uses those web pages to train the model to understand what language is and how words follow other words. So basically it's transfer learning for NLP. It can go up to 1.5 billion parameters. We're not using that bigger one. When they released it in stages. So I think it was 172 million parameters for the first one. Because they said that if they released the big one, it was potentially very dangerous in terms of could be used for things that you may not want things used for. So, for example, there's this case study here of someone using GPT-2 to make a fake person, and I think they were able to create this, run it on Reddit, and it was pretty convincing in terms of being able to post and talk and respond to people. So that's that is, in fact, I click on that link so you can see the address. So this was the paper. So you can obviously look at that at your own leisure, being able to go out and create a fake person. So obviously, only do that in a ethical manner. So we talked about that. So it's a transformer type. What does that mean? So recurrent neural network, STM, all these kind of things. How they understand sentences, they understand them by saying what came before. So the, quick, red, fox. I know I've got that the wrong way around. I did that. I realised now that it should be the quick brown fox. But regardless, quick red fox jumped over the brown lazy dog. So it goes through each one, looks at what happened before, looks at what happened before, looks at what happened before. So it has to go through each single word, understanding it, and it's a recursive process. Transformer type, it tries to do everything in parallel, does everything at the same time. So it has an attention phase. What that means is it will go through and it will understand how all of these words relate to each other. So something like the fox will relate to red and quick, and the, obviously, because it's the fox. The dog will relate to brown and the. So it sees it as a whole, tries to understand the context of how words talk to each other. So so red is describing the fox, but also it might have another layer that's saying fox, red, quick, the, to understand what word comes before as well. So it has that attention layer, then it does a standard neural network, then it does a softmax. So we can see how good this is. We'll do a open demo first, then I'll show you how good we are with creating our Buffy scripts. So this is using, so some really good examples on this page, but this one's using just the GPT-2. So if I say something like, let's create my own one. So if I say Buffy and Giles were killing, let's see how the model works. And this hasn't been trained on. I haven't trained this. This is just the base model. but obviously the base model has been trained with a lot of text, so it might understand what Buffy and Giles in context to each other mean. So we can start to see Buffy and Giles were killing each other for the first time in a while. So they were able to get to know each other better than ever before. Now, last time around this, it did start talking about vampires, so that's interesting. Let's just try Buffy and Faith were fighting. Yeah, okay. But as you can see, it's actually pretty good. It's actually pretty good at creating text. So we could say something like Microsoft Azure. Let's spell Microsoft correctly. Soft Azure, and we can see. Let's actually give Azure a capital. Services team is excited to announce the availability of Azure. SQL 2012. Okay, so as you can see, it's things relating to Azure and Microsoft. And it's basically going off and creating a sentence. So, but like I say, we haven't fine-tuned this. This is just the base model. What we do with the model is we then go out and we fine-tune it. So obviously you can play with that at your leisure. So now we're going to go and we're going to try and create a new episode, because the last one probably wasn't that good an episode. So we're going to create an episode using GPT-2. So let's jump into our scripts again. Where's my web page? Here we are. So this is using GPT-2. So again, we load all the Buffy scripts in, and we use those Buffy scripts. So import GPT-2 simple as GPT-2. We import TensorFlow. We then so I've pre-trained this. So what this is quite good how this works is you run a model, you train it, and it'll checkpoint that model. And so if I were to then train another iteration, it will continue from where it previously had set off. So all I'm trying to do is and this is the model I'm using here is only the 172 million parameter one. There is a 1.5 billion parameter one, and there's a 480 parameter one as well. But essentially, I'm using probably the smallest one to do this. So again, it would probably get better if we went a bit higher. So I've already trained one. In fact, I'll show you how that bit works down here. So training a model, essentially I just say fine tune. I give it my Buffy text, which is basically I put all the Buffy text into one big file. If there you go, 117 million version of it, and then I tell it the name, and then it goes off and it uses my GPUs, and it goes off and trains it. In this one, I just did one iteration. As you can see, I did one iteration, and that took me to 2012. So previously I'd done 2001 before. Now let's go back. So we load our model, and then we can do generate text. So as you can see, let's see how this goes. So Giles to Riley, he's fine. Giles walks over to Buffy and Riley. Buffy and Riley hold hands. Giles to Buffy, very, very, very good. Riley to Giles, look, and let's put this into perspective. Giles looks at them, but they don't exchange any words. So as you can see, it's starting to make a bit more sense. It's not Shakespeare, but there is more of a story to understand. And it comes up with quite a few nuggets, such as it understands that Buffy is a vampire slayer. It understands what the relationships, and some of this can be quite impressive. Okay, so let's just show you this bit. Yeah, so and then we can also understand this model in relation to how it's working. So this is a BertViz. So with BertViz, it's a package that you can use to understand what's happening inside GPT-2. In fact, let's show you this one. So this is how all the different relationships are working. So I've given it the sentence, Faith once more attacked Angel. So we can see that the relationship between all these different words and how they might relate to each other. Where we see this kind of pattern where it's all going up to the first word, that's usually a null. again, that's not that interesting, but we start to see some where it will be so attacked relation. It sees a relation between once and more. Angel, it sees relationship with faith and attacked. So it starts. So you can see in how the network's working to start understanding different words, and we should also see somewhere within it. We should also start to see patterns such as where it's starting to understand the order of words as well. So it'll have a previous word in here. I can't find out where it is, but it should have one where it shows previous to it. So it understands. So it has context of order as well. So it understands context of relationships and how these words interact with each other, and it understands context of order of words, and that's how it's going around creating it. And we can, so here's another window, and Tara, we're playing with magic. So we can see when we go to magic, we could bad example. Oh yeah, no, you can just about see that it's talking to and Tara and Willow. So it's Willow and Tara, and it's holding a relationship between magic. And then we can look at the different layers, and we can look at all these different parts of it to understand this in a bit more detail, how it's getting all these words to relate to each other. So we so I went off and I started generating this model. It took a while, took an hour to process when I was creating it. In fact, let's go to slides because we have these in. I have these in slides to show you how well we did as we processed through. So this is using GPT-2, 160 runs. So this is Sandra oversteps the line, so it starts close to me. She's on the couch beside me. Her hand is in my lap. Pause. So are you going anywhere? Her hand is in mine, and there is something in my hand. Willow looks at me with confusion. Willow, you're not okay with this. So as you can see, it's starting to do a story. It's starting to understand the relationship. It's starting to understand Buffy. There's certain amount of sexual tension, innuendo that they have in there. So we got to about 200 runs. And then we see things such as Spike talks to Xander. Xander looks up from his books. Yes, it's okay. Spike takes a step closer. You understand? Spike still looking down the street. I'm a girl. I got to look like a girl. Spike turns to go, but Buffy steps up to the end of the street. A group of us is standing at attention here. Buffy, I'm with you. She gives some advice to them. Buffy, that just means you want to be there. So, like I say, it's starting to be stories, starting to have some more context. In the interest of time, I won't go through every single one of these. So after 1,000 runs, we got to this script, and rather than reading this script out, we will demo this script. So what we're doing here is we are bringing in some of our cognitive services and our neural voices. With our neural voices, we can, let's show you that demo. I'll show you this demo first. With our neural voices, we can actually create synthetic voices that sound very similar to real voices. So what are we doing? We're connecting to our cognitive services, speech, and we're going through, and I've created these functions that are looking at how each that are basically generating voices. So we give it a type of voice. So in this first one, this is who's going to be playing Buffy, and this is the actual voice is called Aria. And I've set them to be a cheerful voice, and we can have different bits of text. This cheerful, or empathic, or newsreader. We can slow down parts of text. We can speed up parts of text. I'm keeping things quite simple. We'll talk about that in a bit more depth in a bit, but I'm keeping things quite simple. So this is a neural network having cheerful, neural voice rather using cheerful. Next one we have Giles. So we're using English person. This one's called Ryan Neutral. Then we're going to use for Willow, we're going to have Chatty as the type, and that's Jenny Neutral, which is a US voice. And then we have our narrator, which we are using for a narrator, an Irish voice, I think. So let me just have a look. I've lost where the voice is. Oh yeah, okay. So Connor Neutral, which is a Irish voice. And so we, so after done that, we can put this into here, and we can play our series. So I'm going to ask you to rate this, because what we're going to do after this is we're going to see how this corresponds to previous episodes that have happened and been rated on IMDb. So yes, we will ask you to rate this. So let's play it. So pay attention.
Robin, the audio is very quiet. I think you need to retry the audio.
Okay, let me reshare my presentation just to make sure the audio is good. 1 second. And
while you're doing that, would you like me to ask some questions now, or did you want me to say?
Yeah, to ask some questions now while I'm resharing.
So there's one question: after a fake video has been created, is it easy to distinguish this video and know that it's made up, or if it's a real one?
So that's a good question. Yes and no. So it depends on, it depends on the quality. I don't think we're at the quality yet of being able to create videos that you couldn't, with a bit of digging, see some tearing as people's faces move, that kind of stuff. So yes, you could probably do it. We're getting to the point where it's becoming undistinguishable, but certainly at the moment you can. So in that one that I've shown before of Kim Jong-un, you could see as his face was moving, it didn't look quite, it looked good, but it didn't look 100% natural. So we're not at the point of that kind of Running Man being able to create scenes with it and it look completely natural yet, but we're getting very, very close, and the technology is coming on. Okay,
one more question on the one of the original methods you had near the start. Somebody's asked, could you feed the output of the DCNN into the LSTM, and would that improve the learning rate and the speed?
So output of the neural network into the LSTM? Yeah. You probably could do. I'm not sure if it's going to improve. I'm not sure if it would improve or not. So you probably the way that things are moving in the NLP space is it's more about transformer types, such as the GPT-2, BERT, and those kind of things. So LSTM have been good, but they're starting to come not as popular to be used in natural language processing because we have these other techniques now. So if you obviously make you aware of that you can use it, but most of the stuff you would probably be just jumping straight into a transformer type rather than an LSTM style. Okay, so I'm going to play this again. Hopefully the audio will be a bit better.
Hi everyone, I am playing Buffy.
Hello, I am playing Giles.
Hey all, I am playing Willow.
And I am the narrator. Cut to the library. Buffy is walking in. Buffy is dumbfounded.
Oh God.
Oh God.
Buffy, you need to get up.
I'm off.
Right. Well, not till then.
Right. It's okay. I'm getting up.
That's all.
Well, I'm going with you.
You're not going to get up till then.
Well, I'm sure you're not going to, push yourself to. I'm not going to, take on any more responsibility to be more responsible.
Buffy gets up and leaves.
Oh God.
I don't care.
I'm sorry. I don't understand.
Buffy says to Willow.
I don't even understand.
Okay,
Giles stops and looks at her.
I'm not making up my mind.
No, I'm just trying to stay focused.
That's it.
And that's it. Okay, so that's our episode that we created with GPT-2 after 2000. Oh no, it was only 1,000 iterations. So what we're going to do is and this is every end of every episode, you get the mutant enemy, which is the studio that created Buffy and Angel. So what we're going to do is ask you to rate it. So aka.ms/rate Buffy. and we will then we're going to run an algorithm to look at all that's happened, all the ratings that have happened for previous episodes. We'll put that into that algorithm, and we'll get an output and that will tell us how good that episode we just created would be if we had run it and produced it and released it and people have watched it, which you've watched it, and so we're asking you to just rate it. Now please, you're not rating the presentation or anything, you're rating just that episode, so please be honest. If anyone gives it a 10, you don't get out, you don't watch a lot of TV. That's all I'm saying. Okay, so well, in fact, I'll put that in the chat, just so you've got the link. 1 second. Still in the chat. So that is aka.ms/rate Buffy. So that's in the chat. So, and when you run that, you should come in here and you can rate it out of 10. Okay, so while everyone is doing that, in fact, I'll just bring that over here so we can see the scores afterwards. So while everyone is doing that, we'll just talk about the voices. So as I said, so that was all synthetic. We synthetically created the episode. We synthetically created the voices. So we were using those few newer voices. We can do voice tuning as well. In fact, I'll show you how that works. So this is the Cognitive Services Studio for our text to voice. So we can go in, and here you see a cheerful voice, and we can change the stylings as well. So we've got things like cheerful, empathic, newscaster, narration, professional, and then we can hear how the need to refresh because I haven't been I've left that page open too long. Let's just let it refresh. So here we go. It's cheerful one.
That's remarkable. You're a genius.
Actually, yeah, so pretty much the same voice used for Buffy. We have different languages as well.
可以通过停顿里的高级功能 No Break 解决分词引起的多余停顿问题，
So
也可以合成多角色、多情感的有声书，例如
sounds very natural, so it could be a real person talking. So yeah, you can go in here and you can create all this, and as you saw I did before, I created some of these. We can put pauses inside there just to make it even more natural. Okay, so let's jump to looking at how our episode compared. So the first thing I'm going to do is I'm just going to look at see if anyone has voted to see how good they thought that episode was. 1 second. Oh yes, okay, so we have quite a few responses. So the responses we had 9 responses, and so people have said that's about a 3.67. So if they were that's very generous, they would give it a 3.67. So what we're going to do is going to take those ratings, run those off IMDb, run those ratings against the episodes, run a regression algorithm to work out if we can predict them, and then we're going to see how our new script scored. It does score. So it's very simple what we're doing really. So Buffy rating. So yeah, interest I won't run this because I ran this earlier. So again, loading all our scripts. And then we add the Buffy rating that we borrowed from IMDb against the script. So script 1 had a rating of 8.2, script 2 had a rating of 8.0. Just go through that. I'm using what am I using here? I'm using I'm using a neural network, simple neural network that's a regressor. So it's not classification regression problem because it could be it's a sliding scale. So regression neural network. Just run that through. I'm cheating a bit because I haven't put it into testing and training data. I should have put in testing and training data. I just ran them all through as training data. So I've been a bit lazy and got a few corners. But effectively we run through this and we get a RT score of 85. So it thinks about 85% accurate. And our mean squared error is quite low at around 8. so if we plot that on the chart, so we can see the rating we predicted against the ratings, the reality of the ratings. I can't remember which way around we are. I think the orange is the one we predicted. And then if we put that into an order, just reorder it by ratings, we can see that our line is actually pretty good at calculating it. So what we do is we are going to put the script in. So this is the script that we just saw. I added these bits because I found that if I left these bits off, because like I say, I didn't do a very good data quality. If I left those bits off, the script score was lower. So it's expecting those bits to be in there. And we run that and we get a accuracy score of 3.3. So and that was pretty impressive that I've lost it now. The 3.3 our algorithm got, and we had 3.45, so almost perfect. It's quite scary how close that is. Okay, so I'm not going to show you the sentiment stuff because we haven't got time, but I will show you our cognitive search stuff. So we have cognitive search. Within that we have semantic search, and how semantic search works is the old way. If we were querying, if we wanted to do question and answer about the scripts that we have, we could do this is the old way of doing things. You just do a query against it and it gives you some results back. What we've done with semantic search is it does spell check. It does, in fact, let's show you this one. It does a spell check, it passes the query, it looks in the search engine, it does a semantic ranking of the top 50, it uses, understands the relationship between the different words to do that, and then it produces captions and answers. So let's do a really quick demo of that because we're nearly at time. I should have, here we go. So here's a the search explorers. This is just semantic search turned on. Like I say, this is a preview. It's a gated preview. It only came out 2 weeks ago. And I might ask a question. Maybe I've just watched it a bit, and I know the master's been in the first series a bit. Did he survive? Is the master dead? Maybe I missed the end of season 1. So let's search against that. So I ask, is the master dead? And it says the top result I get with 70% accuracy, it gives me the answer: Vampire 1, the master is dead. Someone had to take his place. So it searched through all those scripts, and that's the script it came from. Search all those scripts, giving me an extract that helps answer the question that I'm asking. So yes, that tells me the master is dead. I could say something like, what does Willow do? And that will hopefully give me something that makes sense. So Willow in full dark magic splendor, motion of towns to what. So it's kind of telling me roundabout way that she does use his magic. I could say, does Faith fight Buffy? Maybe I don't understand the relationship they have here. And here we go. So Faith and Buffy are engaged in a vicious fight. So this is all, and we can say who is Willow's girlfriend as well. I'll just do a few more to show you. So here's Willow's girlfriend, and then it goes and tells us Willow's grief stricken. She's always Tara's dead body. Bit of a spoiler. But now Tara is Willow's girlfriend. So I haven't really had to do anything with this. I've just put it through I've just put it into Azure. I've plugged it into Azure Search, and I get all of the benefits of semantic search, being able to ask questions about my corpus of data, to then give me a kind of nice answers that it will find that information out for me. Okay, so we are at time. So open up for any questions, please. In fact, let's have a look if anything's in the chat. If anything I haven't answered. So yeah, like the GitHub repos there, and that's in the chat as well. Yeah, we've answered that one. I'm using Python 3.6 mostly for the stuff. I might have been using 3.7, but it's 3.6, 3.7 for the stuff. And see if there's anything else open. Nope. Okay, so it looks like I don't have any additional questions. So thank you for your time. And that's the end of the presentation. Please come back for the other presentations over the next 6 weeks. And like I say, this will be recorded, and you can get the code from GitHub. With that, I'll hand over to you, Emma, if you have any final bits.
I think you got just about everything there, Robin. So thanks so much for another excellent session. I'm really looking forward to next week. You can sign up now on the series page link. So I posted that in the very beginning. I'll just repost it again for everyone. And you'll also be able to access on-demand content. So today's session will be uploaded there soon, and last week's, as well as details for upcoming sessions too. So everything will be on that series page. So really hope to see everyone back again next week, and enjoy the rest of your evening or day wherever you're dialing in from.